Hello, my name is Santhanamahalingam, Associate Professor, PSN College of Engineering and Technology, Tirunelveli. Today I am going to take the differentiation by using interpolation method. Okay, here directly we will move to some. Here I gave the first derivative formula and the second derivative formula for Newton's forward interpolation method. Now, how will you find the method is a Newton forward or backward? First, we have to decide how will you find Newton forward or backward method. Okay. Now see the x values. X value first, the x value, height of the x value must be same one. The height must be same. Then only you can use a Newton forward method or backward method. Then depend upon your x value, this method will be changes to forward method or backward method. Your interpolate value will be between first two interval, means it is Newton's forward interpolation method. If your x value must be interpolate between 5 and 6, mean you are going to use Newton's backward interpolation method. Here after the differentiation we are going to find the value for x equal to 1. X equal to 1 means it is almost between 1 in this interval 1 comma 2. That's why here we are going to use Newton's forward interpolation method. Okay. Now we will move to Newton's forward interpolation method. Tabular column at first. First write the given x value and y value. Now see how we have to write the finite difference table formula here. First we write x value as it is, then y value as it is. Here see the x value is a 1, 2, 3, 4, 5 and 6. So it is uniformly increased with the height 1. That's why Newton forward or backward interpolation method is be applicable. This is 1, 8, 27, 64, 125 and 2 16s are its y value. This delta y means the difference in y axis. That means the difference in y value. Difference in y value means how we have to find is second value minus first value, that is 8 minus 1. Then 7. Next one is 27 minus 8. So this will goes to 19. Then 67 minus 64 minus 27 as 37. Then 125 minus 64 as 61. Then 216 minus 125 as 91. Difference between that value and its previous value. This is delta y. Delta squared y. Next one is delta squared y. Delta squared y means the delta squared y can be written as delta squared y equal to, this will be written as delta of delta y. Delta of delta y. Okay. That means again you have to find the difference in delta y column. Find this delta means difference in delta y column. So here is a delta y column. So you have to find the delta y squared as like the previous one. We can find it. 19 minus 7 maybe 12. 37 minus 19 18. 61 minus 37 24. 91 minus 61, so 30. Like that you find it. Next delta cube y. Delta cube y means difference in delta squared y. Delta cube y is difference in delta squared y. Use the same method. 12 minus 18 minus 12, so this will turn to 6. Then 24 minus 18, this will go to 6. Then 30 minus 24, this comes to 6. Okay. Delta power 4, that means difference in delta cube y. Delta power 4 means difference in delta cube y. So as like same method, you subtract it 6 minus 6 and 6 minus x as 0. Till the single number is coming, you have to proceed the tabular column. 0 minus 0, so that will be coming as 0. This method is, this table is called a finite difference table. This, okay, finite difference table. This method is called a finite difference table. After finding the finite difference table, you have to find a h value. Okay, move to the next table. We will see how to find the h value. H value is x minus x naught by h. Okay, h value is x minus x naught by h. Here x value is given as 1. X value is 1. X naught means initial value for x naught, initial value for x, and height means difference in x axis. X value is given. X naught means first value in x, height is the difference between x axis. That means, see that here x value 1, it is given in the question itself. So write x value equal to 1. X naught means first value in the x point, x axis. First value in the x axis. Here first value in the x axis is 1. So this is what x naught. Okay. Then height, x naught equal to 1. Height means difference, find difference in x axis. That means second limit, second x value minus first x value. That will be 1. Okay. Then you have to find n value. N equal to x minus x naught divided by h. X minus x naught divided by h value. See this? So here n value equal to 0. Okay. X minus x naught by h. So n value is considered as 0 here. Then write the formula. After writing the formula, we are going to substitute the value. Delta y naught. Delta y naught means first value. Y naught means first value. Where you have to get the first value means delta y naught. That means from delta y you can get first value. Here delta squared y naught means from delta squared y you are going to get the first value. Then from delta cube y you are going to consider the first value. So from each table, from the delta onwards, delta y onwards, first y naught, first you select y naught. That means y value, first y value. If possible, you can write it. Second delta y naught. Third one is delta squared y naught. Fourth value is delta cube y naught. This one delta power 4 y naught, delta power 5 y naught. Here delta power 4 y naught and delta power 5 y naughts are 0, so you don't bother about it. For the remaining you write the formula. So up to third delta cube, up to delta cube you are going to write the formula. Okay, so I write this formula here. This is a first differentiation. This is taken from the original formula of Newton forward interpolation method. In the Newton forward interpolation method, if you just derive the formula, you can get this answer. Okay. In this answer, you substitute all the values and you are getting the answer. By same method, this is for second order differentiation. In the second order differentiation, again substitute all the values, you are getting the answer for second order differential value. Okay. Then in what are the places you are going to apply the interpolation, first order and second order. For that, we are going to see something. First, velocity. For velocity formula is dx by dt. X is displacement, t is time taken. Dx by dt. So first derivative, velocity. Then acceleration. For acceleration, you are going to take a second differentiation, that is dv by dt. Differentiation in velocity is called with respect to time. Differentiation in velocity with respect to time is called acceleration, or this is d squared x by dt squared. So to find the velocity and acceleration by interpolation method, we can use the differentiation formula. This is one case. Next, to find the maximum value and minimum value. To find the maximum and minima, we have to find the polynomial at first. Polynomial will be taken as y. This y will be written as f of x. Then from the polynomial, we can find the first derivative. This is your ordinary method. From this polynomial, we have to find dy by dx at first. Then d squared y by dx squared is second. dy by dx is first. Then d squared y by dx squared is second. Next, consider dy by dx value is 0. Third concept is dy by dx value will be 0. From the dy by dx value will be 0. From the dy by dx, we can find some x values. Substitute that x values in second order to find the function is whether maximum or minimum. Suppose d squared y by dx squared is dou squared or d squared. D squared y by dx squared is, suppose if the value is less than 0, d squared y by dx squared is less than 0, the function is a maximum. Suppose if it is greater than 0, function is a minimum. Then substitute dot x values in y to get the maximum value or minimum value. This is your ordinary process. Okay. The Newton formula also, the interpolation formula also, almost we are going to find the same techniques if polynomial is asked. Okay. If any polynomial is asked, we can use this direct method, or we will move to some other method by Newton's forward or a backward method. Okay. In this one, see what is given here. Your rod is rotating in a plane about one of its end. So in one end, the rod is rotating. If the following table gives the angle theta of radians through which the rod have turned for different values at different times. Find the angular velocity and angular acceleration at t equals 0.7 and at t equal to 0.5. Like the same velocity and angular velocity, velocity means dx by dt, angular means partial differentiation, dou x by dou t. Here dou y by dou t. Okay. Now see this one. See how we are going to write this. First time t. Then we have to find the relation between angular velocity and angular rotation. It is related to angle. That's why instead of y, here we are going to write delta. So t and deltas are given. By same technique, we have to find a finite difference table. Okay. Second term difference means second term minus first term, third term minus second term, fourth minus third, fifth minus second, like that we have to differentiate, fix the table. After fixing this table, you have to write the same velocity formula. Okay. And again apply for acceleration. Here, two different x are given. First, for angular velocity, x value is 0.7. So 0.7 minus 0 by 0.2, that is 3.5. For angular acceleration, x value is 0.5. Yeah, they are giving, see this, they are giving two different x values. For angular velocity, x value is 0.7. For acceleration, x value is 0.5. So two different x are given. First one is 0.7, second one is 0.5. So n is different. So with the help of that n, you have to find dy by dx as velocity and d squared by dx squared is acceleration. Compared to your first model, this may be something easy. Here, by this long process, after finding the long process, you are getting the answer. But by here, by simple application, we can find the velocity and the acceleration of the given values. But you remember one thing, in all the numerical method, this answer will be only approximated value, not exact value. Some small error may come, small error may come. Okay, so that error may be negligible. See the next one. Find the maximum and minimum of the function y equal to f of x from the following table. X value is given, y value is given. See that again x value, all the x values are increased by 1. Okay. So it is uniformly increased. If x values are uniformly increased, then only we can apply forward difference formula. Here you can proceed this by two ways. One is by Newton forward method, we can find the polynomial as it is. Okay. After finding the polynomial, like the previous step, like this step, we can find the answer. This is one case. That is a proper way. Okay. First, we are going to find the polynomial f of x, then find dy by dx, d squared y by dx square, then apply dy by dx equal to 0. You can get some x values, substitute the x values in second order differential equation. In the second order differential equation, if the value is less than 0, the function is maximum. Okay, less than 0, don't forget it. D squared by dx squared is less than 0 means function is a maximum, greater than 0 means function is a minimum. To get maximum or minimum value, substitute that x in your f of x. This is one process. Here also we may use that one. We may use, after finding the polynomial, we can find dy by dx, d squared y by dx squared, etc. to get to maximum or a minimum value. Now see what is how we are finding. Again the same tabular column. Okay, here point is given. We find all the values up to that. Then apply Newton's forward interpolation difference formula and backward difference interpolation formula. See this, here x value is given. Okay, here x value is given. So we are finding dy by dx value. Okay, we are finding dy by dx value. After finding the dy by dx value, we need not find the polynomial directly. We can skip one step. Find the dy by dx value. This is your dy by dx value. After finding the dy by dx value, keep this value is equal to 0. So take x is common, x into x square minus 3x plus 2 equal to 0. X equal to 0 or factorize this, product must be 2, addition must be minus 3. Your product will be 2 plus 2 and addition must be minus 3. Okay. So we are going to find the two numbers as minus 2 and minus 3. Minus 1, minus 2 and minus 1. If we take these two numbers whose multiplication is 2, addition is minus 3. So this will be written as x into x minus 1, x minus 2 equal to 0. So if x equal to 0, so x equal to, now you have three values, x equal to 0, x equal to 1, x equal to 2. After finding this value, now you know dy by dx. Okay, from the dy by dx, find d squared y by dx squared. From dy by dx, find d squared y by dx squared. Here see, dy by dx equal to dy by dx equal to x cube minus 3x square plus 2x. X cube minus 3x square plus 2x. Differentiation means bring the power inside. You have to use that formula, d of x power n equal to n into x power n minus 1. d of x power n equal to n into x power n minus 1. Use this differentiation formula to get the second order differentiation. Use this formula. You are getting d squared y by dx squared equal to 3x squared minus 6x plus 6. Take the differentiation for this. For x cube differentiation is 3x squared. Then for 3x squared differentiation is minus 6x, then for 2x differentiation is 2. So we are getting the second order differential equation. Now you have 3 x values, x equal to 0, x equal to 1 and x equal to 2. Here you have 3 x values, x equal to 0, x equal to 1 and x equal to 2. Substitute all the values here. Suppose I take x equal to 0 in this one. So 0 minus 0 plus 2 positive. So if you substitute x equal to 0, the function is minimum. Positive function is minimum. Suppose I take x equal to 1, 3 minus 6 plus 5. So minus 1 will come. Function is a maximum. When x equal to 2, its value is plus 2, again function is a minimum. So for 0 and 1, 2, the function is minimum. For 1, the function is a maximum. So substitute that values in your second order to get whether it is a minimum or a maximum. After finding minimum or maximum, you have to substitute that value in y. That is one method. Or that is one step. Or you can find a d squared y by dx squared directly for all the threes. X equal to 0, again by interpolation, not by your ordinary method. Again by interpolation, you can substitute x equal to 0 in second order differential equation. Here see this value, greater than 2, greater than 0, positive, less than minus 1, negative, then 2. So in both cases you can get the function is maximum or a minimum. Again, to get to maximum value or minimum value, you have to substitute this value in your original interpolation method. Newton's forward interpolation method. If you substitute all the values, you can get the answer as maximum or a minimum. Okay, so recall once again. First, you have to decide whether the method is suitable for Newton's forward or backward. After Newton's forward or backward, you will take first derivative and second derivative method. These first derivative and second derivative methods are very useful to find the velocity and acceleration or a maximum minimum method. Okay. So whatever they are asking the question, you have to substitute the value and get the answer.